Welcome to the DIY Honda Garage channel. DTC P0328 refers to a high voltage reading in the knock sensor circuit, indicating a potential issue impacting engine performance. In a Honda CR-V 2023 Plus, this diagnostic trouble code, DTC, is generated when the powertrain control module, PCM, detects an abnormality in the output voltage from the knock sensor. The knock sensor is crucial as it helps the engine control module adjust ignition timing for optimal performance and fuel efficiency. If the PCM receives a signal that exceeds the specified voltage threshold, it triggers this error code. Understanding this DTC is essential for diagnosing issues that could lead to poor engine performance, such as knocking or pinging sounds during acceleration. The components involved in this DTC include the knock sensor itself, its circuit connections, and the PCM, located within the vehicle's engine bay and cabin. Identifying the root cause of this high voltage reading is critical to restoring the vehicle's performance and reliability. The knock sensor is a vital component mounted close to the engine block, responsible for detecting vibrations that indicate engine knocking. When the engine experiences knocking, the sensor sends signals to the powertrain control module, PCM, to adjust ignition timing to prevent damage. If the PCM identifies that the voltage coming from the knock sensor is higher than a predefined value, it will record DTC P0328. This high voltage reading indicates that there is either a malfunctioning knock sensor or a fault in the sensor's circuit. The PCM's role is pivotal, as it interprets the inputs from the knock sensor to ensure the engine functions efficiently. If the knock sensor fails, or the circuit is compromised, it can lead to suboptimal engine performance, necessitating immediate troubleshooting. Therefore, understanding how these components interact is critical for accurate diagnosis and repair. Several factors could contribute to the high voltage reading indicated by DTC P0328. The most common cause is a faulty knock sensor, which can generate incorrect signals if damaged or worn out. An open circuit in the knock sensor KS wiring could disrupt normal functionality, preventing accurate voltage readings from reaching the PCM. Additionally, issues in the ground line, KS GAND, can also lead to high voltage signals, as improper grounding may skew the signal output. Another potential cause is a defective PCM itself, which could misinterpret sensor signals, leading to erroneous DTCs. Lastly, physical damage to any components in the wiring harness can affect the integrity of the feedback loop between the knock sensor and the PCM. Proper diagnosis involves checking each of these areas methodically. Recognizing symptoms associated with DTC P0328 is essential for timely intervention. One of the most noticeable indicators is a decline in engine performance, which may manifest as reduced power during acceleration. Drivers may also experience knocking or pinging noises, especially under load, indicating that the engine is not adjusting ignition timing correctly. This can also lead to decreased fuel efficiency, as the engine struggles to operate optimally. The illumination of the check engine light, CEL, on the dashboard serves as a warning signal, prompting further investigation. Additional symptoms might include erratic idling or stalling, particularly at low RPMs, as the engine attempts to compensate for inaccuracies in fuel delivery and timing adjustments. Addressing these symptoms promptly can prevent further engine complications. The first step in troubleshooting DTC P0328 involves preparing the vehicle for inspection. Begin by turning the vehicle to the on mode, which powers the vehicle's electrical systems without starting the engine. Once in this state, inspect the knock sensor output voltage by checking the connector, specifically looking at the 2-pin 2P knock sensor connector. According to the diagnostic guidelines, the expected voltage reading should be approximately 5.0 volts. If this voltage is present, it may indicate that the knock sensor itself is functioning. Hence, other related components should be investigated. Should the voltage reading deviate from the expected 5.0 volts, it suggests that further testing is required on the knock sensor or related circuitry, prompting additional inspection of the wiring and sensor itself. The second troubleshooting step involves disconnecting the knock sensor, 2P, and preparing the connections at both the knock sensor and powertrain control module, PCM. Before beginning this assessment, ensure the PCM connector E80P is also disconnected. Key inspections include checking for open wires in both the knock sensor, KS, and ground, KS-GND connections, as these can lead to voltage anomalies. Using a multimeter, you'll measure the resistance in these circuits, ensuring that it is less than 1 ohm, which confirms a continuous electrical pathway. If the resistance exceeds this value, it indicates an open circuit that may either be within the wiring or a connection malfunction. Documenting these resistance values not only aids in understanding circuit integrity, but also serves as a guide for subsequent steps in resolving the DTC. In the third troubleshooting step, assess the condition of the powertrain control module, PCM. If previous inspections have indicated normal readings in other areas. At this stage, if the knock sensor and its associated wiring have shown no faults, it leads to the conclusion that the PCM could be malfunctioning. This step requires checking for any fault codes stored within the PCM relevant to the knock sensor and other components, as it may provide insight into additional issues that may not have been addressed. If a fault in the PCM is confirmed, this may necessitate replacing the module itself, which is a more complex and costly repair. Understanding the PCM's integral role in monitoring and adjusting vehicle engine performance underpins the necessity of ascertaining its status through rigorous testing before concluding potential replacement. Upon completing repairs related to DTC P0328, it is crucial to verify that the fixes have effectively resolved the issue. Start by clearing the DTCs from the PCM using a diagnostic tool that supports this function. Once completed, reconnect all previously disconnected connectors, ensuring that they are firmly in place to prevent any future electrical disruptions. The next step involves taking the vehicle for a test drive to facilitate normal operating conditions for the engine. During this drive, pay close attention to any lingering symptoms, such as knocking or poor performance traits. After the driving test, recheck the DTCs in the PCM to confirm that P0328 or any other related codes has not reappeared, indicating that the issue has been resolved. A successful repair should show no recurrence of symptoms or error codes, ensuring the vehicle operates within specified parameters. To prevent future occurrences of DTC P0328, implementing a routine maintenance schedule for the knock sensor and associated wiring is essential. Regularly inspect the sensor for any signs of physical damage, corrosion, or loose connections that could lead to improper functioning. Additionally, it's wise to check all electrical connectors and wiring harnesses for wear and tear, as environmental factors can contribute to degradation over time. Monitoring engine performance metrics through diagnostic scanning tools allows for early detection of potential issues before they culminate in error codes. Performing timely diagnostics aids in catching any anomalies early, thereby improving overall engine health. Keeping detailed records of inspections and repairs will also help in observing patterns that may indicate underlying problems requiring attention. In conclusion, DTC P0328 signifies a high voltage condition within the knock sensor circuit, which can lead to significant challenges in engine performance and efficiency. The knock sensor plays a crucial role in regulating ignition timing to avert engine knocking. Therefore, any fault in this area must be addressed promptly. Systematic troubleshooting steps include verifying voltage outputs, inspecting wiring and components, and evaluating the PCM status, ensuring no aspect is overlooked. Regular maintenance practices can greatly aid in preventing the recurrence of such codes, keeping the vehicle functioning smoothly. Additionally, documenting the details and findings throughout the troubleshooting process is essential for future reference and aids in maintaining transparency with vehicle owners. Properly understanding and addressing DTC P0328 ensures that your Honda CR-V continues to perform at its best. Please like and subscribe to the channel. See you next time.